You ever stop and think about what's actually going on inside your smart TV, or your car's dashboard, or even your washing machine? Well, there's this entire invisible world of technology at play. A silent network of hidden computers that are, quite literally, running our modern world. So let's pull back the curtain and take a look at the hidden intelligence that makes everything tick.
So let me ask you a question. It sounds kind of like a riddle, right? What could possibly connect a high-tech space explorer, a humble kitchen appliance, and the car you drive to work every day? You know, they seem worlds apart, but they are all connected by a fascinating piece of technology that you use every single day, probably without even thinking about it.
And there it is. That's the answer. Every single one of them has a specialized brain inside. A computer that isn't built for browsing the web or writing emails. Nope, it's engineered to do one thing and one thing only, and do it perfectly. Whether that's navigating the surface of Mars, heating up your lunch, or making sure your car's engine is running just right.
All right, so let's dive in and really break down what these hidden computers actually are. Because this, right here, is the foundation for so much of the tech we talk about all the time, from IoT to AI.
Okay, the key words here are special purpose and dedicated task. That's what it's all about. An embedded system is the ultimate specialist. It's this tight combination of physical hardware and the software that's written directly onto it. We call that firmware. And the whole package is designed to do just one job, reliably, super efficiently, and often for years and years without ever being turned off.
To make this even simpler, let's use an analogy. Just think of an embedded system like a very simple organism. It needs to sense what's going on around it, it needs to think about it, and then it needs to act. It's got senses, a brain, and muscles.
So first up, you've got the senses. In the tech world, we call these sensors. These are the little components that grab information from the real, physical world. Things like the temperature in your room, how fast a wheel is spinning, or whether a door is open. And they turn all of that into an electrical signal the system's brain can actually understand.
Next, of course, is the brain. This is usually something called a microcontroller or MCU, which is basically a whole computer on one tiny little chip. It takes all those signals from the sensors and uses its programming, its firmware, to figure out what to do next. It's not running some big, complicated operating system. It's just running its dedicated instructions over and over and over again.
And finally, we get to the muscles. We call these actuators. These are the parts that take the brain's commands and turn them back into a physical action in the real world. So when the brain says, go, an actuator is what actually spins the fan, locks the door, or just turns on a tiny little light.
So you can see the whole loop right here. You've got input from the sensors, processing by the brain, and output through the actuators. This simple but incredibly powerful cycle is pretty much the heartbeat of every single embedded system out there, from a tiny digital watch all the way up to the flight controls of a passenger jet.
Now this brings us to a really, really important point. We all have these super powerful general-purpose computers, right? Our laptops, our phones. So why do we even need these other specialized systems? Well, there's a very good reason your toaster doesn't need to run Windows.
So it all comes down to a totally different design philosophy. A general-purpose computer, like your laptop, is a jack of all trades. It's built for flexibility, it's got powerful hardware, and it eats up a lot of power. An embedded system, on the other hand, is a master of one. It's laser-focused on a single task, it uses just enough power to get the job done, and it's often built to last for, get this, 10 to 15 years, compared to the 3 to 5 year life cycle of a phone. It's all about rock-solid reliability and efficiency over just being flexible.
Okay, so why does any of this matter to you right now? Well, because understanding this isn't just some abstract tech trivia. We are living through what you could call an embedded renaissance, and this technology is becoming more critical than ever before.
And this quote really says it all. Embedded systems have gone from being just a small component inside a device to being the absolute foundation, the backbone of huge innovations like the Internet of Things, electric vehicles, and AI. They are the silent engines of progress.
And hey, the numbers don't lie. The global market is already huge, over $110 billion, and is projected to jump by more than 50% in just the next 5 years. This is not some niche little market. It's a massive pillar of the entire global tech economy.
So where is all this growth actually coming from? Well, consumer electronics, our phones and smart home gadgets, they still make up the biggest piece of the pie. But look at this. The fastest growing sector, it's automotive. As cars basically become computers on wheels with electric drivetrains and smart safety systems, the demand for this tech is just exploding.
And this whole renaissance is being fueled by some incredible new trends.
We've got things like Edge AI, which lets these tiny devices run machine learning all by themselves, without the cloud. We've got open-source hardware, like RISC-V, making it cheaper for anyone to design custom chips. And security is finally being built in from the ground up, not just added on later. It's a whole new ballgame. Now, when you see all this growth and all this innovation, that means one thing: massive opportunity. So let's talk about what this means for you and how you could actually be one of the people building this future. Let's just take India as a perfect example. It's become a huge global hub for this kind of work. The market there is set to grow at over 10% every single year for the next several years. That kind of sustained growth, it signals an incredible worldwide demand for engineers with these skills.
And that demand is spread across all the most exciting fields in tech today. Automotive and EVs are leading the way, for sure, but so are consumer electronics, industrial automation, medical devices, and of course, the entire universe of IoT and smart gadgets. This isn't a career that's tied to just one industry. It's a skill set that can open doors pretty much everywhere.
And these are the specific jobs that companies are hiring for right now. Roles like firmware developer or automotive embedded engineer are some of the most future-proof jobs in all of tech. Why? Because they demand a mix of both hardware and software skills, and that combination is incredibly valuable and really hard to automate.
So if you're sitting there thinking, okay, this sounds amazing, but where do I even begin? What's the one skill that opens the door? It's embedded C. It is the fundamental language for controlling hardware directly, for managing memory efficiently, and for writing that reliable firmware that makes all of this technology possible. It is the absolute place to start.
So think about it. We've gone from simple little controllers to these tiny hidden computers that are now learning to see, to hear, and to make smart decisions right where the action is happening. They're not just following basic instructions anymore. They are actually starting to think. So the real question isn't what they can do, but what will you teach them to do next?